Hello everyone. We are still within our introductory topics in view of preparing you for Calculus 1. In Section 3, we will look into simple factoring and factoring by grouping. Factoring is most likely the most important skill you will need to possess in order to have success in calculus. It's going to be used throughout the course, right from the early stages of limits and all the way to curve sketching at the end of the course itself. In this section, we'll focus on two of the most basic factoring tools, which is simple factoring and factoring by grouping. So what does it mean to factor? Well, essentially, factoring means identifying and extracting elements that are common to a sum or to a difference of terms. Perhaps it's easier to make the analogy when we think of what it means to distribute. Distribution, in this case of A to the sum or to the difference of B with C, can be easily applied by multiplying A to B and multiplying A with C to create a sum of two new terms, AB plus AC, or in the case of the subtraction, AB minus AC. So this is called distribution, or distribution to a sum or to a difference. Factoring is the exact reverse operation, where we recognize A is common to the term AB and AC and is extracted. In order to describe the process of simple factoring, we're going to examine how the expression 8x cubed minus 12x squared can be factored by following some guiding principles. First step is we're going to identify the factors that form the terms of the given expression, and we're going to focus on those that we recognize as common. 8x cubed has been rewritten as 2 times 4 times x squared. I've rewritten 12x squared as 3 times 4 times x squared. This makes it a little bit easier to see how 4 is a common multiple of 8x cubed as well as 12x squared. Also, x squared is a common term from 8x cubed and 12x squared as well. If necessary, you can rearrange the terms and highlight them. So I've chosen some color codings here where 4x squared, the common terms appearing in 8x cubed and 12x squared, have been highlighted. And we can then recognize how 4x squared plays the role of what we called A earlier when we described distribution. 2x and 3 can play the roles of B and C respectively. From this point, we are just using distribution in reverse, which we'll simply call factoring from this point on, where A is extracted. So 4x squared is a common factor for the difference 2x minus 3. You can reassure yourself that you have done the work correctly by redistributing 4x squared to 2x minus 3 and verifying that you get the original result back. Here's a slightly more complex situation involving more than one variable as well as numbers. 5x squared y cubed plus 25x y to the 4 is a sum of two expressions that have a certain number of elements in common. Notice how 5x squared y to the power 3 and 25x y to the power 4 share a 5 as a factor. Both have x to the power 1, and both have y to the power 3. If we extract 5x y to the power 3 from the first term of the sum, we do have to remember there is an extra x left behind since we started off with x squared. If we extract 5x y to the power 3 from the second term, 25x y to the 4, you have to remember that you've also left behind a multiple of 5 and an extra y. In total, 5 times 5 is still 25, and a y cubed times y is still y to the 4. We've just rearranged the presentation. Then notice how 5xy to the cube becomes a common expression, plays the role of the a, as we said earlier, and can be factored. Again, going up in difficulty level, here we have an expression that involves negative exponents, as well as operations or terms that we would like to find factors for. We're going to try to factor the single fraction that results from this operation and try to factor the numerator as well as the denominator if we can recognize anything common between them. First and foremost, we've dealt with the negative exponents appearing on the powers of x. X to the minus 2 and x to the minus 3 have respectively become dividing x squared and x cubed terms. So these are from the laws of exponents seen in previous videos. Before we can combine these fractions, we have to make sure that they have a common denominator. Notice how x squared and x cubed already have x squared in common. We're simply missing an extra x from the first fraction. You'll notice that I have multiplied by x above and below to create the x cubed and generated a new x on the numerator of the first fraction. Having a common denominator now allows us to regroup the numerators together and therefore have a single fraction. At this stage, you'll notice the denominator is a single term. It's not a difference nor a sum, and therefore cannot be factored. At the numerator, however, we have a difference. Both 4xy to the power 3 and 8y squared have 4y squared as their factors. These become the common factors that can be extracted. And now we have a factored single fraction. Factoring by grouping is involved in situations where simple factoring is repeated. That sounds strange, but we'll see how that's presented. Again, there are links that can be made with distribution, but it's a bit harder to see than it was for simple factoring. Grouping is worth considering as a factoring technique when an expression is formed of 4 terms, as we'll see. Consider the expression AB plus AC plus DB plus DC. Now, rather than thinking of all 4 terms at once, look at the first pair of terms and the last pair of terms, which have, in one case, an A as a common factor, and in the second, a D as a common factor. So from the first pair, we could do simple factoring and extract the A. From the second term, we can also proceed to simple factoring and extract the D. Now here is where grouping will either prove to be efficient or will fail to work. What has to be left behind are terms that are now similar, or in fact they have to be identical. Notice how after extracting the A and the D from the first and second pair of terms, we've left behind common B plus C expressions. Well, at this stage we can think of B plus C as a common multiple to the first and to the second term of the sum. In other words, we can do simple factoring again, where now B plus C is extracted, leaving A from the first term behind and D from the second. In French, we say double distribution ou double factorisation, because as you've noticed, we've done 2 different steps of factoring. First on each pair of terms, and then on the common element that was generated in that starred step. As an example, let's try to factor the expression x cubed minus 3x squared plus 4x minus 12. The only reason why you would be tempted to try factoring by grouping here is by the fact you recognize there are 4 terms. Looking at the first 2 terms and the last 2 terms separately, you'll notice that x cubed minus 3x squared have an x squared in common. 4x minus 12 have a multiple of 4 in common. And therefore we can factor or perform simple factoring on the individual pairs. X squared is extracted from the first pair, 4 is factored from the second pair, and this is where you will be able to tell that factoring by grouping is successful, because now we have generated a common x minus 3. X minus 3 being a common term, it can be factored, leaving x squared from the first expression and plus 4 from the second. Once again, here we have a difference of, an expression formed of 4 terms, or formed by 4 terms. We're going to go by hopefully grouping and wish that it will be successful, unless, in this scenario, we recognize that simple factoring can be attempted first. So this is a bit of a warning. Before moving on to grouping, despite the fact there are 4 terms, you always want to consider simple factoring as your first option. In this example, 8xy to the power 2, or xy squared, is common to every term appearing in this expression containing 4 terms. And therefore we can start with simple factoring. We have left 4 terms behind, or actually we've left xy squared as a multiple of 4 terms, and we're going to attempt grouping on the content of this parentheses. Now 2 minus 3x, there are no common elements to 2 and 3x aside from a 1, and therefore we'll just kind of bite the bullet for now and factor a 1 or extract a 1 from each term. The second pair of terms, 4xy minus 6x squared y, have 2xy in common. And notice we've extracted 2xy from each element of this pair. Doing simple factoring on each individual pair, here's again where the magic has occurred. We have a 2 minus 3y that has shown up as a common factor. And we can therefore extract it, leaving the 1 and the 2xy from the individual terms we used to have.